Hey guys, welcome back to the channel. So in this video I'm going to upgrade my CNC, and this is actually a 3-in-1 CNC, and I made a few parts over this entire build so that if anybody is interested in making a 3-in-1 CNC, then you can check the description section. There's a link of entire series. So before jumping to the main section of replacing the parts, let's have a look onto the problem. So the main problem in this machine is the carriage where the router has been mounted, and there is a significant amount of flex into the carriage. I have to eliminate this thing to get a perfect cutout, and that will also going to increase the depth of cut and also going to save a lot more time during the machining process. So there are two main problems in this area. First of all, the linear bearing are not supported over the entire length, and that is the main cause of the deflection, and you can clearly see in the video that within a tiny amount of force the entire carriage starts to bend. Second thing is the size of the carriage is a tiny bit large, so I am going to reduce it up to some extent. Third thing is that I am also going to change the spindle and change it with the Makita trim router, which is much more robust and able to do a much deeper cuts compared to this spindle. And also I'm going to make some fan brackets for the Z-axis so that I am able to keep the motor cools, because I'm going to use these motors at full current. So these are the few things I'm going to do. So without further any delay, let's start the build. So along with those linear bearings, I also need to change the mounting plate, because the whole location is a tiny bit different than the previous linear bearings. So what I did here for the second linear rail is that I just fixed the bearing first, and then by taking the reference of the upper rail I just take the whole location of the second rail and then fix it to its place, and it really works, and you can see the result. So one more thing I'm going to do here is to mount a angle over this area so that I'm able to close this gantry, and I think that will going to increase the structural stability of the gantry at much higher extent. So this is the angle piece I am going to use there, and I already drilled down the holes, and going to use the previous drilled holes which are already used for the linear bearings to mount this angle piece onto the gantry. So now I am going to change the distance between both the front and back plates, and by having a shorter span that will also reduce the flex into the carriage. So these are the two plates which I am going to modify, and the amount of distance I am going to reduce here is equal to the thickness of this router mounting plate. So here for the drive mechanism I also need to do a little bit of change, and I made a slot here so that I am able to fit that belt into that slot, and I have to make sure that that belt will not interrupt with the router which I am going to mount over here. That's why I need to make that slot. So after making so many changes, there is still some amount of flex left into the gantry, and I am not able to remove this much because when I apply the force the whole frame going to be moved. So I think it is pretty okay, and I am using a pretty high force to do this flex. And you can also notice that when I apply the force, not just the carriage flex, the entire gantry flex with that force, and that will prove that the carriage is much more rigid now compared to the previous setup. So now I'm going to make some cuts and give you a side-by-side comparison of both the previous setup and the improved setup. So that's pretty much all about this video guys, and if you like this video then definitely hit the like button, and if you didn't subscribe to the channel then consider subscribing. Till then, goodbye, have a great day.